Hey guys, Cam here at Papa's Fix It Shop. Anybody that's watching knows that I'm not a machinist. I've been playing around with it since I retired, like a couple of years before I retired. Before that, I was a master mechanic. I worked starting in the late 70s as an import mechanic. I did all the import cars. Porsche, Mercedes, Audi, Volkswagen, Mazda, Master Tech, and all that. So anyway, the last 20 years of my career, I worked at the Border Patrol garage as a mechanic and a fabricator and a truck driver. And I ran CNC, like a plasma cam, and I did all their engravers and stuff. And as mechanics, you run a brake lathe, but that's not really a lathe. Well, it is a lathe. It's not, all you can do is break discs and drums. In any event, my policy is if you're not learning something new every day, excuse me, you better get on the ball. So I take on projects that I don't know how to do so I can learn how to do them. Yeah. So this is a piece of 41L40. It's 3/8 diameter, starting and 12 inches long, and I spent the morning truing up my tailstock by cutting tiny cuts until I got it down to where there's only about a half a thousandths variance from one end to the other, and that's mostly the cheap little lathe I have. It's not a very big lathe. This is like getting pretty big to try and spin on it. But what I'm making is for the same guy that I made a filament welder fixture a few months ago. This is going to be a cutter to cut 3D printer bits and pieces of leftover filament, failed prints that didn't come out right, and if you can shred them into uniform particles the right size, then you can feed them into an extruder and make new filament with them. So he asked me if I could make one for him. Basically just a business end, you know, the little cutter part. So this piece of 41L40 right here is going to be the cutter, and I'm going to do it the hard way. I'm basically only going to use a cutoff tool to cut a series of grooves, certain depth, so there'll be thin, you know, little ribs sticking out between all those grooves, and then I'm going to use the mill to put cutting teeth on it in a circle around there, and then drive this against another piece of hardened steel. In that case, it'll probably be A2 steel, to where these little cutters will fit through the groove in the A2, and it'll make a nice little spot to grab the plastic and snip off a chunk, and we're aiming for around 5 millimeters by 5 millimeters. So stay tuned. It's been a job. I actually had to, it was hilarious. I had a bunch of lathe tools laying around that I picked up here and there over the years. And if you're a lathe guy, you know what this is. It's a lathe dog. I'm doing this guy between centers. And to do that, you got to grab this guy with the lathe dog. Normally it goes like this, it clamps on and hooks into the chuck. This guy's kind of big for my lathe. It will swing it, but it almost, you know, that little lathe jumped up and down like a kid getting candy at Halloween, man. It was crazy. So I ended up making one that just fits on my 4-jaw chuck, and it can clamp on either end. If you can see close to this, this end's the one that was in the lathe dog, and now I'm going to flip it around. I'm going to machine this end back down to here, to this size. So should be an interesting project, but I think it'll be a while. I'm going to have to be very careful, see if I cannot, you know, can avoid scrapping this piece of steel. It's not horribly expensive. It's about 30 bucks, but I certainly don't want to scrap it. So it's going to start out with me actually sitting down and drawing a picture to show the spacing of all these grooves I got to cut and I'll keep you posted along the way. I'll play some videos. So, as always, it's the day after Christmas. Merry Christmas. I hope everybody had a great day. And I'll point out that a fellow made a comment on one of my pages, and he said, it was all in Spanish. He said he likes to watch the videos. They look really good, but since I speak English in my videos, it would be kind of nice if I tried to present it in Spanish. So my Spanish is not well. I can understand a lot of it. I can speak a lot of it. I can read it fairly decent, but to carry on a conversation, see, you know, lo siento, mi español es muy limitado. Por escribe palabras en español es muy difficult. Now, see, there I blew it. So I'm going to try and incorporate that because it'll help me learn Spanish better. I mean, I've lived here on the southern border of the United States in Arizona since 1958. Now at the end of my life, everybody in my immediate family, like my wife and all of our kids and grandchildren, are all Hispanic because I'm the only white guy in the family now, except for my brother and sister and my cousins. We're all from Michigan. So stay tuned to see if I can butcher Spanish and scrap expensive bits of high carbon steel. Thanks for watching. Hey guys, I think we're doing another Chingaderas and Jesus clips. Started out almost hilariously because I broke my lathe. And as part of that lathe, I was doing another project. And it's this. I don't know if you can see that. That's a real close-up view of a piece of bar stock, 41L40 annealed steel bar that I'm making a project to build a plastic shredder for grinding up plastic bits that are left over from 3D printing operations apparently. So like I said before, I always take on jobs that I don't know how to do so I can learn something. So I took a couple of sheets of paper. This is actually the first one. This one and this one were both before I knew my lathe was broken. In fact, I broke the lathe, or it chose that moment to fail while I was doing that shaft, the first steps of it, so it's not done yet. So I don't want to cut the teeth on it until I'm done with the lathe, because then I'll have, if I cut all of those those nice cutting teeth on there, I'll have it spinning on a lathe. It'd be really dangerous. So I wait until I get the lathe working. So I'm translated all of that, my drawings, into a stack of papers on how to approach the tool path and how I'm going to cut those teeth. And that's what this next series will be about, is me making this plastic shredder starting from scratch with the shaft of the cutter head. And as I go along, I'll explain my rationale on how I'm doing certain things the way I'm doing. So make sure this guy's still playing. Apparently it is. Appreciate you watching this plastic shredder project. And other good stuff that's happening in the future. Welcome to 2021. It's probably my first video of the year, so that's cool. Talk at you later. Okay, well, this is hole number 14. Or, well, slot number 14, I should say. So I'm not using the mist in this mister, just using the air to blow chips out. And I can also go with my old brush and throw a little cutting fluid just to, this is a carbide cutting tool, and it's cutting this thing really nice, but with the cutting oil, it's easy to tell when it's getting too hot or, you know, how hot it is, because I can see if it starts to make smoke. But anyway, I'm on like the max speed on this mill, which is 1700 RPM. So start out by coming down where it's right about to touch. All right. So that's about 848, you know, on my readout. And that's because I'm going down to the bottom is 0. When I get down on the bottom, it's 0. So right now I'm at 8.5 millimeters from the end of this groove. So, in case you're interested. Oh, by the way, I'm running this all in metric. I don't want to start a fight with my fellow Americans, but metric just makes more sense in a lot of ways. To me at least, but I've been dealing with metric since the 70s because I was dealing with metric since the 70s because I was an import mechanic. So anyway, without further ado, I'm going to cut this last one. So I start by going from 8.5 down to about 6 millimeters on my readout. And bear in mind, I'm heading towards the 0 mark. is the drawing. You can see this pattern. It's right here. All right? And if I get up close to this, see that says C1. So I designated this a cutter section or segment or however you want to call it. There's 14 of them. So if I want to identify this specific one, that's cutter 1. And then 2, 3, 4, 5, all the way over here to cutter 14. All right? So here's the thing about these cutters. Each one will have 5 teeth. Each of those teeth will be 72 degrees away from each other in a circle around that cutter. And so the first one, if I have the cutter oriented on 0, and like right now this is 0, right here, it's on 0. So if I wanted to make this one, cut on 0, the next one over is going to be an 18-degree offset, farther over. And the next one, 18 degrees. And the next one, 18 degrees. So what happens is that 18 degrees goes into 72 5 times. So by the time you get to the 5th one, it's going to be back up to the beginning again. And it'll be 2 and 4. 2 full 5 sections, and then 4 more will be to the end. So to identify which one I'm working on at any given time, I've got this guy. So this is segment 1, section 1, and it's pattern A, where it starts at 0. Yeah, well, I'll do this. Each one of these, the first one is A, pattern B, C, D, E. There's 5 patterns, right? Depending on when the offset, how far the offset is. So then I go to the next drawing. So pattern A starts at 0, 72, 72, 72, 72, 72. Pattern B starts at 18 degrees past 0, and so on and so forth. And down here, this tells me what the readout on the rotary table is going to say in degrees at each location to begin my cuts. Then we go to this guy. First cut will be with a very small, like a 5mm carbide square end mill, and I'll cut a flat on the end of that, 5mm wide and across the end. So it's 90 degrees. I'll just drop it in, cut it across, go across. And I have to do all the teeth like that depending on where they land. So I have sheet after sheet that tells me where those coordinates are. At the end, I go back around with a ball tip, like a carbide ball end mill, and I put the radius cut across the end of there to make the final teeth. All of this just to make the cutter. Because it's all one piece. This is all going to be one piece of metal.